7 and last. So we have our dominantly Arcos, okay? And the grains are pretty homogeneous and they're angular, which strongly suggests the source is nearby. Now, when we talk about transportation of particles in sedimentary rocks, we talk about net transportation. The more angular something is, the likely the shorter the transportation is. The more rounded it is, the longer it's been moved downstream, usually downstream, okay? Or knocked up along a beach, whatever. However, what do I mean by net transportation? I mean the amount that rock or that particle, that sand, say it started out almost cubical, has moved net-wise. You can, distance-wise, total, like a sand grain on a cliff on a beach, can move 10 meters and be rounded. That doesn't mean it moved only 10 meters. It's probably been washed up, washed out, washed up, washed out, washed up. That thing could have moved 20 kilometers net, even though it's only 10 meters from its source. You see what I'm saying? Waves and velocity of water and stuff like that. A rock, and that can also fool you too as to how far it's been transported. If a rock gets hung up, if a stream loses velocity, but it keeps moving, but not enough to move that rock, it'll round it more and more, even though it hasn't gone as far. That's why it's important to look at the rock as a whole. And we do know from where I pulled this from, the source is not that far, right? It's right under this rock, okay? And formed, the source of the highlands for it. So the rhyolites, the basalts, the latites, all of the mid-continent rift. I already told you it's the Copper Harbor Formation, Union Bay member, okay? So that's where this comes, Precambrian, about 1 billion years old, a little older than that. It is technically Mesoproterozoic. It's not Neoproterozoic, technically. Barely, though. So this type of on and off, this angular conglomerate interbedded with laminated sandstones, this is very typical of a fluvial stream environment. This is not really alluvial fan. This is more fluvial stream. And every once in a while, you would get, even though this is more rounded, that doesn't mean it's been transported necessarily as far. This piece of rhyolite was probably derived from lower in the Copper Harbor. It probably wasn't derived immediately from the source. It was eroded Copper Harbor being reincorporated into Copper Harbor, because the base of the Copper Harbor Formation is conglomeratic. The Conglomerate Falls and Gorge Falls member, right, are dominantly conglomerate, and they'll have round pebbles to boulders of usually basalts and rhyolites in it. But they haven't been transported very far. It's that streams thing, you get a storm, these rocks get loose, they fall, they get transported, and then they get stuck because the braided streams that rolled off the cliffs lost energy, but they're still there. So it'll round it more and more. So you got to look at more than just rounding to tell if something's been transported far or how far. It's all that kind of thing. But that gets you environment. Since we are near the source, the ultimate source, which is the mid-continent rift volcanics, this is above that. It's the Oronto group. It's a basal formation of the Oronto group. It's the first actually clastic sedimentary unit that of any relevant thickness in the mid-continent rift in the Lake Superior area. So, we know this stuff wasn't transported very far, okay? Maybe a couple kilometers, all right? As where even the more pebbly stuff at the boulders, that stuff may have been moved 100 meters, but it's rounded. So the size can tell you too. You're not going to move outside of a glacial situation. You're not going to move big boulders like this, 100 kilometers in a stream. in a small stream. Okay, it's just not going to happen. Once it's there, however it got there in a flash flood, rolled downhill or whatever, it's just going to get rounded as that stream pummels it. So the size of the rounded particles does matter too. If it's small and rounded, it's probably been transported pretty far, like sand size. But all the sand in this is still subangular to angular. So even the quartz in it was derived from nearby. And if I pulled zircons from this, and then zircons from the first outcrop of basalt I see, or mid-continent rift volcanics, I'll probably get the same thing. And that does happen, okay? But fortunately for the Copper Harbor conglomerate, we have actual volcanic units in it, lava flows that have been dated. So we know this stuff, for as thick as it is, I want to say maybe 1,500 meters at the most. So what's that? 3,000, 4,000, 5,000, no, 3,000, 4,000 feet, something like that. About 1,500 meters probably took 9-ish million years or less to be deposited. Because once the big continent rift spewed 99% of its volcanics, that magma chamber became empty. So the basin started to subside rapidly. So the basin had no more base support. So it started to subside when that rift failed, and the conglomerates just shed down into it. Okay. But generally the Copper Harbor does fine upwards. But you get the Union Bay member. Actually, there was a little bit of coarsening within the Sandstone Falls member, I believe. Anyway, because the Louisville fans kind of returned for a little bit. But anyway, I digress. So, interpretive wise, even though I've already given away the formation, the nature of this rock appears to be a fluvial stream environment, dominantly. All right, and storms, flash floods would occasionally roll down some pebble-sized stuff, but no big boulders. So although we're close to the source area, we're probably not near it. And like I said, we're probably a kilometer or so away here. And that's, if memory serves, I believe that's what it is, maybe 2 kilometers, something like that. I forget exactly. So we're not like right up against it. Okay. So anyway, what do you think of that? Huh? How does how does it make you feel about how not simple this is? Oh yeah, and a side note, never ever use a friggin' Rock ID app. Because I did on this. Guess what it called it? Called it a basaltic breccia. Yeah. Anyway. Don't use those. That's it. If you have any questions or comments, please leave them below, and I hope you learned something.